Today we're going to talk about safety controllers. We're going to go over some safety solutions in the robotic side. We're going to talk about access passages, and then we're going to walk through a little bit about some solutions in the AGV side, which is automated guided vehicles. And then the very end, we'll talk a little bit about some types of services that we're able to provide. In an application that you see here, where there is a box being erected, where we have a magazine that is being filled with cardboard that could potentially have a risk when the machine is running. If the cardboard was to run out, this could create a potential hazard for the operator by way of crushing or smashing his fingers or arms if they try to reload it. There are other times where it could also shut the machine down and make your process less efficient. So SICKS came out with a safety controller called FlexiSoft and uses multi-pulse photo eyes to be able to watch the level measurement of the magazine as the cardboard boxes are in there. So as they go in, it's running just fine. When the sensors sense that the level is low, it sends the information to the FlexiSoft controller, and the FlexiSoft controller stops the machine. This gives the operator time to race over, reload the magazine, reset the safety, and restart the process again. And again, a complicated application could be solved with a simple safety controller, which is a safety relay with some logic that we can change on the inside and just two photo eyes. The FlexiSoft could be added. We can add slices to this as we grow in our application, or if the application gets bigger. We have different types of modules. We also have gateways to be able to communicate to common bus systems like a PLC or HMI. In applications where you have volt-free contacts like non-safety switches, locks, e-stops, there's a lot of times we see these wired back in series. So in this case, we have 6 doors, safety doors, switches that are wired in series. They're volt-free contacts, channel 1 and 2. Normal situation we see all the time. Door 2 gets open, both channels loses volts, and it tells the system to shut down. You have to reset the system, the safety system, and then press start for the operation to continue on. But what happens when you have a short circuit? Something happens to the wiring of one of the channels. So this can be actually what we call fault masking. So what happens is when you open door 2, it recognizes channel 1 is open, so it shuts the safety system down. It works exactly like it's supposed to. But the second you close the door and you go to try to press restart, the system recognizes that there is a sequence fault. So you can't get it to restart, and you're trying to figure out why. So what do? Well, the first thing you start doing, you start opening doors, pressing buttons, trying to figure out exactly where the issue is. So as you open up door 1, we see channel 1, channel 2, they shut off the system. We close it. Now the sequencing fault that we had is now live. Now the fault that we had is now masked. System resets and start. This could be really dangerous because now our redundancy is gone. And if we have another fault, this could actually cause a serious problem in our safety within door 2. So let's say later down the line, a couple weeks later, we have another short on channel 1. Now the operator has the ability to open that door, and the system now thinks, the same way it happened last time, still thinks that it's good when really we broke safety. Because of this, the connection of interlocking safety device from the ISO standard and the technical article that comes with it, fault masking happens when you have a connection of devices with free contacts in series. There's 2 ways to get around fault masking. 1, you can use switches with monitor semiconductor outputs. Or 2, you can use a safe sensor cascade like one we're going to talk about with FlexiLoop. Switches with monitor semiconductor outputs are nice because they're not voltage free. They require to have that voltage there. So they're continuously being monitored at all times. The second the door opens, we lose that voltage. We actually get the highest performance level PLE because of this. So in the last situation, we looked at volt-free contacts. This is a risk of fault masking. So technically we do have a reduction in performance level because there is a risk of a fault mask. Whereas we can solve the fault mask, but we have to use a series of connections of OSSD outputs, which is only a specific sensor type, so it limits you. What if you wanted to take the OSSD and the volt-free contacts and be able to have them in the same system? SICK came out with FlexiLoop. These nodes can come up to 32 different nodes per each loop, 2 loops per one little slice that you see there. We're able to have full safety of PLE and collect the information diagnostics of what's going on with the sensor. We're always consistently pinging it and being able to see that, yes, the door's open, there's a circuit, there's some discrepancy issues. And we're able to use that using FlexiLoop with FlexiSoft. SICK has also came out with a new safety controller called Flexi Compact. It's meant for really small space savings and for high speeds. Main module has 32 points of I/O, and we can add other modules up to 12 as the system grows or as big as your system needs to be. On the front side of the unit, we have a transfer plug that we can change. We connect to the front side with USB to be able to do fast configuration transfer. On the front side here, you can see that we can change those plugs if there's a certain style that you like. The front plugs are easy to plop off to be able to wire, and the clever design that's used is to be able to swap out the module when needed. The gateways also have a nice quick setup and diagnostics on the front panel of that. And it's a super efficient safety controller because it does safety over EtherCAT based backplane. The very front port has a Modbus port that we can use for easy HMI integration. And because of that backplane, we have a very, very fast shutoff time of 4.5 milliseconds. So really good for small, compact, need to be fast safety. When moving over to protecting things, we look towards light curtains, and light curtains can come with a bunch of different features. One of the things that SICK has done is created a light curtain where you can add plugs to the light curtain to add the features that you needed per your application. In an application where we need to be able to mute out the light so product can go by, we can use 2 signal mutings within the light curtain without the extra needed parts of another system. We can also do reduced resolution. In an application like a brake press that you see here, where we're bending metal across the face of the protection field, we want that piece of metal to be blanked. We can reduce the beam size 1 to 2 beams and be able to still protect the operator from crushing his fingers, but for the product to still be in there for a bend. In applications where you use the vertical orientation of the light curtains, we also put a horizontal orientation and bring them in cascade. What is this reason? In the case of where the operator broke the vertical plane, if the horizontal plane wasn't there, the operator on the other side you see here could reset and start the machine up, and we'd have an issue. But because we did this cascade, this operator has to let that clear out before he can be able to clear the safety. The smart presence detection gives us the ability of the shavings of wood, metals, even gluing process. We can avoid those nuisance trippings. In applications where we need variable protective field widths to change as your machine moves from one side to the other, we can use light curtains like you see here, where they're attached to the orange carts and protecting the operator as he stands in a certain field to be able to not put his hand below where he can get trapped. So we can be able to change those field sets as we go. A lot of these are basic functions within the DTEC 4. But what's nice, as more functions come and more features come, instead of replacing a light curtain, you just need to replace the system plug. This gives you the ability to stick with one light curtain and throughout your entire plant and just changing plugs. One of the plugs you can use is IO-Link. We can collect IO-Link information and do measurement capabilities like a measurement light curtain and share that info. In cases where we're going back to doing muting, we need photo eyes to be able to mute the light curtain, and those photo eyes can become a problem on the overall system. In this case, two photo eyes on one side tell it to turn off, and the other one tells it to turn on, or turn off, then turn on. This adds more sensors, more bill of materials, more things can break. Remove that and put 6 safe entry exit FlexiSoft controller, and we can be able to do safe entry and exit without muting, with muting lights. This all comes with FlexiSoft controller and the logic built in, so it doesn't have to be using a flex or a SICK light curtain. It can be other manufacturers. It's where the controller is, where's the gravy. In this case, same box going through. We're able to mute that out, and if someone was to stick their hand through that, it would shut the process down. In applications where we're doing robotics, in this application here, you would have to create more space to be able to put the muting eye footprint. In this case, we're able to shrink the footprint because of the removal of the muting eyes. In cases where you have multiple lanes with multiple different products, shapes, and sizes, you can be able to bring all those light curtains back to one safety controller. So one safety controller can do a lot of these for you. If you have a box that's not supposed to be there, or as a flap is bent up, like you'll see coming through here, this box not supposed to be there, it actually recognizes that, sends information to the safety controller, and notifies the operator of an infringement. That tells the operator, we have an issue, someone broke, we have a part not going through. Or in this case, operator thinks, hey, I'll just walk right behind the object and try to trick it. You can't. It has to be the same size, same dimension of what you programmed it at. So this is our new way of muting, safe entry exit. Now to do a different way, we use safety scanners called the microscan that has 9 meters of protective field, 275 degrees protected. We use a technology called HDDM, which is high definition distance measurement. We're able to ignore sparks, ambient light, or certain dust particles when in operation. These safety scanners now are very compact in size from before. They're about the size of a pop can. And the type of mountings that come with it makes it very flexible to mount it in a number of different orientations, and also included with standard M12 cabling for easy wiring. The software is called Safety Designer. It is a free software that you can download off the website. We use it to configure the field sets of the safety scanner. This is plugged into a USB port on the front of the microscan. And we're able to create a protective field like you see here. And if an operator breaks that protective field, it shuts the machine down, where he'll have to go clear the safety and then restart the computer or restart the process. In applications where you're working with collaborative robots, we use our safety scanner in combination of our FlexiSoft controller. So in collaborative robots, we tend to need to work next to them consistently. Every time we get close to one, we can't have one shut down all the time. So what we use is speed reduction. In the case of the warning zone there, operator walks through, slows the machine down. Now, the second I break the protective red field you see there, the robot stops. As I walk away from it and everything's clear, it does an automatic restart so the operator doesn't have to do it himself if he forgets. What happens if we don't have a collaborative robot, or we have a lot more dangerous robotic cell like you normally see? There's still other ways to be able to work around the robot and still protect your operator using sequence monitoring. So we can use these field sets, these protective field sets, to start slowing the robot down as the operator gets closer to the robot. In an application here where we're having a drilling process, the robot's going to do some drilling and they'll have to change out some different parts. And the operator has to reload those parts. So as you see, the operator is going to walk into the cell. The machine starts slowing down, recognizing he's getting closer, gets to the protective field that says stop. If he turns around and walks the same way he came back, the machine will start to speed up and then do an automatic reset. When I'm a maintenance guy and I start walking up to the machine, instead of shutting everything out, I can walk right up to the robot. It'll completely shut, get into home position, stop. I go do my additions or my maintenance things I need to do on the robot. I walk out, it won't restart. You'll then have to reset the safety and restart the machine. In situations where a product falls off or an operator's trying to get around the safety, the robot recognizes that the operator's walking in the same sequence but changes direction, which makes the robot stay. It's not fulfilled, and the robot will completely shut off. So as the operator walks back out, this will not automatic restart. He will have to clear the safety and then restart the machine again. We can then take safety scanners and put them in a vertical orientation and make passageways, protective passageways. And an operation that you're seeing here, a material transport, people can get crushed as products moving in and out. You typically see this, some type of rotary locks or some kind of physical guarding that's actually protecting people from getting in, but there's still a big hole and access point. It's rigid and it's inflexible, especially if you do a product change. We remove that. We take two safety scanners, point them at each other. In conjunction with our FlexiSoft controller, we're able to use these blue sets here, these blue field sets, to let product in, mute out the AGV. As it loads up and comes back out the other way, we're then able to mute out the product and not mute out and notice that any kind of operators coming in and out. So as products flowing, operators like, hey, I think I can sneak right through there. Well, you can't. The system's going to recognize, it's going to even recognize you come out. You can't even trick it coming out. You have to go reset all the safeties and reset the system. And we see this in this type of application quite a bit. And like I said, those blue field sets are the trigger. So in this case, it triggers, it does a blank of that product, but everything else is protected. So we see it a lot in overhead cranes or any kind of product that's moving in a linear transport from one location to another. We also have with our safety scanners called the FE Pro system. We use this mainly with AGVs. This gives us an advantage to have up to 8 protective field sets at one time and monitor those field sets, as well as changing up to 128 different cases. As we are going through a process, if an operator gets close to it, we have certain field sets to slow the machine down and then eventually stop if you break a protective field. In AGVs like this that you see, typically you'll see 2 safety scanners in the corners to do a 360 around the actual AGV into using our FE Pro system, SipSafe, into the FlexiSoft controller. We're able to collect information, speed up, slow down. We use the navigation information we get from the safety scanners to know where other robots are and other properties are within our navigation system. If we're trying to get around items, you see as those things change, that's changing and speed up and slow down. You'll notice that it actually grows the field sets. The blue that you see here are contour detection. So I'm approaching a machine, or if something's approaching a basket towards a robot and it needs to be in the spot before I do a picking, we can use the scanner for those, and it can change a case saying, yep, I pulled up to the machine. I'm doing my work, it changes its case, it changes its field sets to protect around that machine and the product itself. So as a person comes and approaches it, it slows down. He's 50% right here. He walks in just one more, shuts the machine down. So it's real slow here. If he's even done with his process and the operator's clear, it'll check, make sure the operator's clear, everything's good, switch the cases. Now it's got another set of field sets. Now it's in navigation mode. And we use this quite a bit, FE Pro system within AGVs. If you have an application where it's an existing system and you're not sure where to start, one of the things we can do is we can come and take 3D images of your existing system and be able to create a 3D model using 3D lasers to be able to recreate your system and put in safety solutions so you can see how the safety it looks on your system, how it's going to affect your system, and ways that you can better your system using this process.
Thank you, Andrew, for providing us with some of the details in regards to many available safety components that can be utilized for a variety of safety applications. I do have a few questions for you. In regards to safety devices versus non-safety devices, can you explain the difference between these devices and how the global safety standards, for example, PLC, PLD, PLE, would apply to them?
Yeah, without getting in too much into the details of the PLE, PLD, just high overview. Your PLE, this is based off the risk of your machine. PLE is the highest. PLD is usually where you see your safety scanners. And then as you get less is where we get into more standard sensors. So to answer your question, a non-safety rated device is going, or a safety rated device is going to have redundancy in the electronics, and the non-safety rated device is not going to have that redundancy.
Very good. I am aware that there are two types of safety devices that can be used for the FlexiLoop system. Can you explain the difference between an OSSD device and an EMSS device?
Yeah, so most of the time you see OSS devices being safety scanners, light curtains. We talked about it a little bit earlier when we were talking about the fault masking, OSSDs for monitoring the contacts. So there are some out there for that, but most of the time, any of your voltage-free non-contact switches or interlocks are literally going to be the ones that are going to use the EMS modules.
Okay. So let's say I have an existing FlexiLoop system installed for my safety application. How flexible is FlexiLoop when it comes to adding more devices to the safety loop?
Yeah, so when you add a safety loop, so we have a loop sitting here with just a couple nodes, what you can do is at the very end of the loop, you have what's called just a little terminator. And what happens is this thing is just pinging all the time. So we can have 32 of these nodes, one loop, two loops, and one slice here. So typically what you'll see is I can add up to 32. If I go into the system and I build a machine that has 20 e-stops on it or 20 door switches, but my standard one, that's the max I'll ever have, but my standard is 10, we can actually pre-populate in the software 20 of them. And if on your first system you only put 10 on, you won't have to change that program. It'll automatically recognize that there's only 10 there. But as you add more of the same sensor to it, that's already pre-populated in the software, you don't have to go back. And so it's very flexible from that standpoint.
Okay. So my next question is about the MicroScan 3. Can I use multiple safety scanners to monitor specific zones within one safety area?
Yeah, so a lot of times you'll see people use multiple safety scanners. We can be able to do like a daisy chain, like star topology, where we can connect multiple safety scanners and run it with a one home run cable back. Each one's addressed so we can collect information from that. So we can do that. The other thing to kind of keep in mind is what I talked about earlier, the safety scanners, most of them, when you see, hey, we have multiple field sets, they'll really only have truly one or two safety protected fields. So an output, an OSSD output. They may have two on a good day. Most of them have one. So when when you want a protective field here and here, some of the newer scanners actually have 8 protective field sets. So there's a lot of times where a guy may use 2 safety scanners, but some of the newer technology may be able to get away with it with just 1.
Very good. So I understand that Microscan 3 utilizes the SICK patented high definition distance measurement, otherwise known as HDDM, time of flight process. Can you briefly explain that process and why the Microscan 3 has an advantage over other comparable products?
That's a great question. The easiest way I think I can explain it to you about the HDM, this scanners, older scanners, is like talking the difference between watching standard TV and HD TV. You're still getting the same picture from a normal scanner and this scanner, but we're getting clearer picture. The picture we're getting is better data, more data. So that allows us to be able to see through things. So, if it's, we got fog or dust, welding sparks hitting the face. If you didn't have the HDDM, you wouldn't be able to ignore those. So it gives us that ability to see with a clear eye.
Okay, appreciate the explanation. When you were explaining the features of the Microscan 3, I noticed there are multiple ports on the Microscan 3. What can those ports be used for?
Yeah, so the ports back here can be used for a number of different things. We'll just pick a couple. One is like we talked about. We can do some daisy chaining. We can bring a couple different scanners together and bring one home run back to the safety controller. We can also collect data, measurement data to using CIP, collecting that information and doing some different functions that way, as well as we can be able to hook up to a device called the event cam. So the event cam that you see here, this little blue device, this thing, if we create a field set and I break that actual field set, it'll take a picture, a colored picture before and after that infringement. So typically when we see someone break a field set, we know safety was broken. We know where and we know roughly about how big, but we really don't know exactly, was it me that stuck my foot in there, or was it a wrench that fell through? We're not really sure. This gives us a clear event, a clear eye to be able to see, hey, when someone infringes this, I take 2 or 3 pictures before, 2 or 3 pictures after, and I might catch a 30-second clip. We can do a bunch of, we can do up to an hour of video stored onto this unit, and we can just share that information as that happens.
Okay, very good. Can I use the Microscan 3 safety laser scanner in an outdoor application?
So the Microscan 3, no, but there is one that looks identically the same as this. It's got an orange instead of a yellow, and it is called the Outdoor Scan 3. Functions very similar to this unit. It is just rated for outdoors, and I believe so. It's the first safety rated certified scanner out there.
Excellent. I have a question that involves the Microscan 3 protective fields. You mentioned those during your presentation. I was curious to know, are the protective fields adjusted via the hardware or by software?
So both. The software you're changing, you can make those changes in the software. So a lot of times you'll set that all up, but the actual changing from case to case is going to be more from a hardware standpoint. So I set all my field sets up, my case is here, and then I may make a change based off some kind of feedback. I may have a sensor that sends me an input back to the scanner. I may use my PLC using an Ethernet cable string and actually trigger it that way. So there's a number of different ways, but mainly from a hardware standpoint, that's how we trigger and change those field sets.
Okay. So I can appreciate all the functions that the Microscan 3 can offer, but let's say that I have an application that requires a smaller scanning area. Are there any other SICK products that can be utilized for this type of application?
Yeah, so great question. We do have another version that just recently came out called the Microscan. It's like this tall. I don't have one with me just yet, but yeah, it's the smallest safety scanner on the market. It does about 3 meters. A lot of capabilities, not as much, but it would be the step down version of that. We also, depending on your, we talk about, the PLE, PLC, PLB, where are you in your risk? We can also use certain Depending on, we can use PLB for small AGCs. So think of like Walmart, where you see those little small AGVs that are cleaning floors nowadays. They're going really slow. They may run over your toe or something, you know, but you really need navigation, a little bit of safety. You don't need the PLC or PLD, but you might get away with, you know, this or the PLB. Then we have some stuff called the TIMS in our LiDAR portfolio that has very similar features to what some of the microscan and the nanoscan can do, from, you know, field sets, cases, and being able to collect measurement data.
Last question for you. You mentioned that SICK can help with the safety system design. Where would I start with developing my safety system?
That's a great question. So a lot of times we talk to everybody and we always ask, do you have a risk assessment on your machine? And whether, have you done the risk assessment? Have you brought a third party? Is there some standards you have a customer or an industry that is telling you that you need to uphold? So a lot of times we say, start with a risk assessment, maybe get a third party to help you out with that as much as you can. There are third parties out there that specifically do that. One thing that's nice about SICK, they do that service as well. They can come in, do the risk assessment. They'll give you a document, they'll review your machine, and basically just tell you where the risks are and basically how high that risk is. What's nice is they can then come, if you want some consulting on how to actually solve the problem, use the solutions. They can either come to guys like us, come use SICK as well to design that. Then the customer can install it. And then usually you want a verification. And that's where a lot of people stop. There's like these processes, and you got the risk assessment, you did all the protection, you did everything right, and you forgot to verify. Whether that's bringing a company in that's basically saying, you did the risk assessment. Yep, you did the risk assessment right. You did this stuff right. Awesome. Should we verify and put our stamp on it? And that's starting to be a lot more important these days. There are certain industries that are wanting that TÜV certification, and certain customers are requiring that. So if you ever run into a spot where you might need help with the risk assessment portion only, or the consulting and the, you know, putting this together only, or just the verification, we can do what parts we can, you know, that you need as a customer. Or if you're like, man, I just want someone to do it all from start, we can do that as well.
Very good. Thank you for answering all my questions.
Thank you. That's all that we have for today. We really appreciate your time. We've got some questions that we know we got to get to, but we're trying to cut short on time, so we know you guys are busy. We'll get back to you on if you have a question that you asked, we'll reach out to you directly and we'll answer that. But last thing is, because you guys attended, we're going to be sending you a nice little box.